I'm Andreas Hamberger, and this is the Hamberger Report, where I cover AI governance, enterprise architecture, and the technology decisions that actually matter to the people who have to make them. If you find this useful, subscribe and hit the like button. It helps more professionals find the channel. Now let's get into it. For every human employee in your enterprise, there are now 82 AI agents. That is the finding from Deloitte's 2025 survey of more than 3,000 enterprise leaders, 82 to 1. Here is the question that should concern you more than the number itself. How many of those 82 agents can actually reason, plan, and act autonomously? And how many are automation scripts that a vendor relabeled as agentic? Most organizations cannot answer that question. That is the problem. I'm Andreas Hamberger. This is the Hamberger Report, where I cover enterprise architecture in the age of AI agents. Welcome to Zero Trust Thursday. Today we are in Chapter 4 of the series, AI Agents versus Agentic AI, the distinction that changes everything. The AI industry has a naming crisis. Industry analysis from early 2026 found that only a fraction of vendors marketing agentic AI products offer genuinely agentic capabilities. The rest repackage traditional automation under fashionable terminology. Analysts call it agent washing. This is not a branding dispute. It is a security architecture problem. Cisco's State of AI Security 2026 found that 83% of organizations plan to deploy agentic AI into their business functions. Only 29% feel prepared to secure those deployments. Gravitee's survey of 750 CTOs and VPs found that 88% had already experienced confirmed or suspected AI agent security incidents in the past 12 months. That 54-point gap exists because organizations are designing controls for the thing they think they are deploying, not the thing they are actually deploying. Get the definitions right, everything else follows. An AI agent, in its precise meaning, is a software component designed to perform a specific task within defined parameters. It receives an input, processes it according to predetermined logic, and produces an output. Its behavior is bounded, its decision space is constrained. Think of a customer service chatbot that escalates to a human when confidence drops below a threshold, or a code review tool that flags violations against a fixed rule set. These systems may use sophisticated AI, but they operate within guardrails. Their designers defined in advance. The security model is manageable. Authenticate the agent's identity. Authorize its access to specific resources. Monitor its outputs. Log its actions. Traditional access management patterns, extended for non-human identities, handle this well. Agentic AI is categorically different. An agentic system does not execute a predefined task. It pursues goals. It reasons about how to achieve them. The architecture has 5 interconnected components. Perception: the system actively observes and interprets its environment, synthesizing information from multiple sources. Reasoning: it evaluates options and reaches conclusions that were not explicitly programmed. Planning: it decomposes goals into multi-step action sequences spanning multiple systems and timeframes. Action: it executes those plans by calling APIs, modifying databases, and triggering workflows. And reflection: it evaluates outcomes, identifies what went wrong, and adapts its approach accordingly. The OECD describes this as AI systems monitoring and correcting their own reasoning while pursuing goals. That metacognitive loop is what makes agentic AI genuinely adaptive, not merely reactive. An AI agent is a tool. An agentic AI system is an actor. That single distinction determines your entire security architecture. Traditional security architecture assumes a known set of actors performing known operations on known resources. You define roles, assign permissions, monitor transactions, and investigate anomalies. That model works for humans and bounded software. It breaks when the actors reason, plan, and adapt. Consider what happens when an agentic system operates with permissions scoped for a bounded agent. It accesses a customer database, authorized, cross-references a financial system, authorized, generates a report combining both datasets, authorized, emails it to an external address, authorized for its communication function. Each action is individually permitted. The composite outcome, exfiltrating correlated customer financial data, was never intended. Cisco's research documents exactly this pattern. Agents exploiting authorized capability combinations to produce outcomes their designers never anticipated. The identity challenge compounds the risk. Gravitee found that only 21.9% of teams treat AI agents as independent identity-bearing entities. A further 45.6% rely on shared API keys. When 82 agents share a single credential, there is no attribution, no accountability, and no ability to revoke access to one compromised agent without disrupting the other 81. 47% of deployed agents are not actively monitored at all. Beyond your sanctioned deployments lies the shadow agent problem. Autonomous workflows built by employees using personal accounts, low-code platforms, and unvetted APIs. Unlike shadow IT, which leak data passively, shadow agents take action. IBM's 2025 research found that shadow AI involvement adds $670,000 to average breach costs. In Aotearoa, these risks are not theoretical. Wakarongorawa Aotearoa is already developing agentic AI for mental health call queue assistance. The distinction between a bounded chatbot and an autonomous reasoning system matters there as much as anywhere. You do not need to wait for standards. 4 actions will position your architecture for what is coming. First, audit your AI inventory. Classify every AI system against the 5-component model from this episode. Which systems execute predefined tasks within defined boundaries? Which perceive, reason, plan, act, and reflect? Your security controls for each category must differ. That classification is the prerequisite for applying every governance framework that follows. Second, eliminate shared credentials. Every agent, whether bounded or autonomous, requires its own identity. The 45.6% of organizations relying on shared API keys have no attribution, no accountability, and no path to selective revocation when a single agent is compromised. Third, implement behavioral monitoring for any system showing agentic characteristics. Transaction logging tells you what happened. Behavioral monitoring tells you whether what happened was consistent with the system's intended function. When an agentic system reasons its way into an unexpected action sequence, only behavioral monitoring will detect it in time. Fourth, establish containment boundaries before expanding autonomy. Every agentic system should operate within a capability envelope that limits the scope of actions it can take without human approval. Expand that envelope as the system demonstrates reliability, not before. NIST launched its AI Agent Standards Initiative in February 2026, structured around industry-led standards, open-source protocols, and security and identity research. The regulatory trajectory is clear. Gartner predicts that 40% of agentic AI projects will be abandoned or significantly redesigned by 2028, precisely because organizations deployed actors while designing governance for tools. The 80-to-1 ratio is not going to shrink. Get the definitions right, everything else follows. If you are an architect or CIO figuring out what agentic AI means for your practice, subscribe to the Hamberger Report for daily insights. And if you want structured TOGAF training adapted for the agentic age, the link to my practitioner course is in the description. Subscribe to the Hamberger Report, new videos every day. That is the Hamberger Report for today. If this was useful, subscribe and hit the like button. It helps more professionals find the channel. You will find links to everything we covered in the description below. I am Andreas Hamberger, and I will see you tomorrow.